So yeah, it's just this cartoon is really nice. I like it because it really sets the scene of where we were when we first started the project, and we started seeing what was happening with the different IMI projects that we were supposed to be serving. I mean, so the problem was this really is this whole ad hoc integration that the data integration only happened when there was a specific analysis in mind. So the integration was always targeted towards achieving the research question, which is actually right. I mean, this is how things happen. You start with a research question. But then this already can start a bit more after you've organized your data structure, because if you've done the integration for a specific question, it doesn't work for another question. And this sort of summarizes, again, the scene that we were looking at. Obviously, eTrix had a hugely dedicated whole work package on standards, so they were recommending the use of standards, but really there was no tooling to try to put this into action. And we obviously, the curation of the data was specific to the tools. So the tools that you chose to curate and load the data into sort of specified for you what sort of curation you need to do, and it was only the people who knew how to use the tool were the people doing the curations. So sort of as a consequence, the focus on the technology is more prominent. So let's curate data for clinical, let's curate data for, we have gene expression data, we have sequencing data. It's all about the data in order to make sure that it actually curated and loaded into in the database. So this all was part of this whole ad hoc analysis that some people made the choice. We want this data set, we want that one, we want to integrate them, put them together and load them into Transmart, the tool for choice for analysis, and then start doing the exploration of the data. So in that way, because again, the domain model sort of underlying the exploratory mechanism of Transmart is widely adopting the I2B2 schema, which basically sort of follows that sort of concepts. You create from these concepts a concept of cohort criteria to create, you get a patient set, and then you start building your subset and your cohorts, and you start building your analyses accordingly. So that, as I said, so this was really flexible for creating these patient sets to start doing hypothesis testing. But then if you go up to that idea of concepts, these concepts that you see in the tree, how are they structured? How are they organized? How are they related to each other? How does the design element decisions of the study as a whole apply to these concepts, and how are they related to each other? Sort of the conclusion, or sort of the message, we sort of started seeing that it was really flexible for data analysis, but rather rigid for data management. So we started looking at what a data archive needs in that case. It needs consistency within the data. It needs consistency across the data, so the annotation, the guidelines, and the annotation patterns should be consistent across. And it needs a standardly defined data model. So I mentioned briefly on the previous slide that the data model of the Transmart was the I2B2 based one, which is again, it's a very flexible data warehouse. I mean, it is a data warehouse, and data warehouses are meant to be, in a way, very flexible with the different elements in it. So as Star Schema treats everything as concepts. So the idea was to build an archive. You need to have a unified data model that glues together the standards that are available for the elements that you work within, to provide you with this then structured and organized semantic and syntactic validation across the data. So, and obviously that sort of, now sort of fast forward to today, that sort of all fits in with the sort of same motivation, same sort of plans now that we're all going towards, that the data should be findable and all the sort of the different elements of the fair data principles. And so that really converges onto these requirements that we still up today we are actually working towards. So obviously the whole, if you want to do this, then metadata preservation is key, and that the standards come to rescue. That's how you start achieving all these different consistency across the data. So Barcelona 2014, this was sort of the put forward objectives of building a generic and semantic syntactic infrastructure, which then developed into study repository. So 2015, we actually had a proper proposal for the work. So now it's actually presented as the harmonization service platform. So not just the study repository, but the metadata, the standards repository that will support the curation efforts, as well as the pipelines of the data, ETLs before and after, and how to integrate it with Transmart to build that new sort of framework that Eve has just presented. So fast forward 2017, we have today built up this study repository, the standard compliance, where you can define your project in a standard compliant matter. You define the templates for your data to load them, be able to explore them, create data sets now that are research-specific question, data sets oriented, that you can download and load into your analytical platform to start doing the actual analysis from there. So that was sort of how we would directly interact with Transmart. You got the data, we had Transmart ETL tools, created Transmart curated files, we loaded my2v2. So basically what we've inserted now is this extra layer before that, where you actually work with the data from the sources, but you make sure that they actually fit into that standard representation, so that now the accessibility of the data itself is always standard, going back to that common interface. This is sort of the general way of when we start looking at data management, data governance, these roles come up. And so we try to see how and where do we actually satisfy these different requirements for these different roles. Data stewards, where they want to be able to work with structured data sets, where they could map the data to, preserve the study metadata, have an integrated data source where they can bring in these data into it. Data custodians to work and maintain this data. They want to have tools that give them pipelining and batch loading of the data in it. Data consistency across the data loads and across the different data sets. And obviously data access, to have a structured data access for exports. So you've seen that before, so sort of the evolution of the Atrix platform it presented itself in that way, that we have now, Transmart has been pushed into the analysis user space, where data is already in a structured, and then this whole layer before it. That's sort of how we can see that data, and actually you've seen in use cases, a lot of the use cases we've defined in that is this idea of hypothesis-free exploration of the data, where you just see the distribution of the data across different concepts and how they could dynamically have this visual analytics exploration of the data. So yeah, so the work itself, so this is sort of, puts and defines where the structure of the whole sort of initiative. The work itself, obviously, we had to build that metadata framework, the standard that we've been talking about, that is inspired from the community standard. We didn't want to build a whole new thing. We wanted to just see this obviously was there for clinical standards. People from the omics communities have worked on standards like ISA. So we wanted to bring all these initiatives on board, try to create this hybrid data model where it will actually cater for now what is the domain of translational research data. The way we wanted to enlist the metadata across the different, in the data domain, goes across 3 different representations. We wanted to represent the input of the data in a standard manner, so that's what we refer to as the data set model. It's the structural metadata. How do we get the data into the platform? So by defining these different data set templates, that's sort of your input into the infrastructure. So by defining these different template data sets, you know that this column is where you would find the name of the test, that this column is where you're going to find the unit. So the next level is then, once these data are received, obviously this is how you define a general sort of investigation, where you have your subjects recruited, you run some clinical assessments for them, where you have samples extracted from them, you run assays. And then at the other side, now thinking about the data analytics or the export side of things, you don't expect users to understand an SDTM table that has a column called the VS or RES for the result of vital sign. So you basically want to provide the data accessibility, a really generic API for querying this data across these different domains in a way that is not specific to a particular standard. So that's what the observation model is for, where it's actually the part where we refer to the harmonization. This is where all of these different models and of the templates get harmonized into a very common and simple generic model. This is an example. So subject, treatment, a data set for adverse events will have these variables, data set for vital signs will have these variables, but these variables are represented in the observation model as generic descriptors that will be exactly the same, regardless of which data set they come from. So the process is, you achieve the data set structuralization, you achieve the semantic harmonization, then you achieve the linking and the gluing into the context of the study. So the platforms within the whole EHS infrastructure is obviously a new data repository for the harmonized data, for storing, exploring, and integrating. It's basically the implementation of this new data model for translational data. And then there's also the tooling that would enable the workflows of getting the data in there. So that's it, just these are the different technologies we've been using. This is basically the workflow. Users, you would bring in the data, you would go through the first step, which is sort of making sure that you get your data structured to these data sets, using the recommendations from the tools of the ontology and harmonization. You get the standard templates, you get the data in the standard templates, you load them in the database, you then get to the next step where the contents of these data sets are harmonized with the terminologies that are of choice. Then basically that's get all matched up into the database with the observations, gets loaded into the data model now that is consistent across all the data, which now gives the users this exploration of it in a standard way. And then finally getting to that explorer where the whole idea there is that it caters for that data user who's searching for the data and with a research question specific, and then basically they click on the different concepts. The idea that the structure of that interface is always going to be consistent. There's always a panel for subject data where the elements here are defined in a standard compliant manner. Same thing with the clinical data. This is all sort of seen as compliant, and when you click on any of these observations, you see the distribution regardless of any pre-association to a previous or another concept. And the idea is that now you can just filter and choose these different concepts, create your queries, check them out, and also bring in the data from molecular observations. You're linking clinical, subject, molecular to check out your data sets, which now become your sort of endpoint to start loading into your favorite. So basically what you'll see later that EHS finishes by producing data sets. Transmart and with the borderline project, it starts by picking up data sets. So right now, as Iki mentioned, we are testing it with an IMAC project by Safe. They've got their own data loaded in it, and created accounts for them. We have this demo site, which unfortunately doesn't have the real data set. Obviously, it's just one unit public data set, which is not very rich, so it doesn't really do justice to the whole application, unfortunately. And we also worked on a Docker container, which we also piloting with another project testing it.
Okay, thank you. So lots to cover.